Hi folks, we're going to take a look at number 7 from page 263. So they give us this function here, and they want us to prove that the derivative of this function is equal to 1 minus that function squared. All right. So since we want to prove that two sides of an equation are equal, the way we're going to do is we'll start with one side and see if we can manipulate it so that we can arrive at the other side. Or perhaps we have to work at both sides separately and then show that they equal to the same expressions. Okay, so I'm going to start with the left-hand side here. So on the left-hand side, we're just taking the derivative with respect to x. So here we're going to have to use the quotient rule. So let's take the derivative of the numerator. And since this is going to come up, it's always e to the 2x. We'll kind of do it slowly once, but then afterwards we'll just write it out. So here again, 2x is like my u, so the derivative of e to the u is just e to the u, so e to the 2x. All right, and then we have to multiply by the derivative of 2x, which is just 2, and I'll write that in front. All right, and of course, minus the derivative of 1 is just 0. So there we have the derivative of the numerator times the denominator function. All right, minus the numerator function, so e to the 2x minus 1, times the derivative of the denominator function. But hopefully you can see that I'm going to get the exact same derivative as before, because the derivative of plus 1 is just going to be equal to 0. So 2e to the 2x. All right, and all over e to the 2x plus 1 all squared. All right, so now let's do some simplifying here. So I see that I have 2 times e to the 4x. When I multiply these two, I just add the exponents. And I notice that I'm going to have another 2 times e to the 4x, which is being subtracted. So that's just going to be 0. So those are just going to cancel each other out. And so the other one is I've got 2e to the 2x. And here I'm going to be subtracting negative 2e to the 2x. So 2e to the 2x plus 2e to the 2x is going to be 4e to the 2x, all over e to the 2x plus 1 all squared. All right. Now, on a test, you might want to actually expand all this and do it a little more carefully. But just again, you can see that this expression here minus that expression there are the same, so they cancel each other out. And then I have this expression plus, because of the two negatives, that same expression gives me 4. All right, so at this point here, I have to show that this is equal to 1 minus this function squared. And I don't think that that's going to be too easy to do at this point. So I think what I'm going to do is work with the other side of the equation and see if I can eventually get to the same expression. All right, so I have 1 minus y squared, and y squared is going to be just the square of this function here. Now, in order to be able to work with it, I'm just going to, right off the bat, square both numerator and denominator. So I'm going to write this as e to the 2x minus 1 squared all over e to the 2x plus 1 all squared. Okay, this is just equivalent to squaring the whole expression. All right, so now I'm gonna, subtract these with a common denominator. So here, the common denominator is this expression here. So I'm gonna have it here, e to the 2x plus 1 squared minus e to the 2x minus 1 squared all over e to the 2x plus 1 squared. Okay, so good news is I already have the same denominator as I have in the one on the left-hand side. So that's good news. I'm just going to have to do some work here to show that the numerator is equal to 4e to the 2x. Okay, and at this point here, this stops becoming a calculus problem and just becomes an arithmetic problem. Okay, so I'm going to square this binomial. Okay, so it's the square of the firsts. So e to the 2x all squared is going to be e to the 4x. All right. Then multiply the first and last, so e to the 2x times 2. Those are your middle terms, so plus 2e to the 2x, and then plus the square of 1, so plus 1. And then minus, we're going to have something almost identical here, except the middle terms are going to be negative, so this is going to be e to the 4x minus 2e to the 2x plus 1. Okay, and I think we can see where this is headed at this point, because these are just going to cancel out. The ones are going to cancel out, and the only thing I'm going to be left with here is 2e to the 2x plus 2e to the 2x. So that's 4e to the 2x all over e to the 2x plus 1 squared. All right, and that's just equal to, we have that the left-hand side is equal to the right-hand side. Okay, so we've proven what we set out to prove. Okay, so just to recap, there actually wasn't anything particularly special about this question. You know, they just gave us a function and they told us show that this equality is equal. So we started with one side, went as far as we could, worked with the other side, showed that they ended up at the same spot. And so we achieved what we had to achieve. Okay, that's it for this one.